18, the condensation of steam on horizontal tube banks. So previous video, example 18, I've already covered the horizontal tube. So now what if we have condensation of steam on horizontal tube banks? So before that, I will change to pen first. So pen color black. So this is the question. Previous question we already answered it, the horizontal tubes, and then the next question is this: repeat the preceding example problems for the case of 12 horizontal tubes arranged in a rectangular array of 3 tubes high and 4 tubes wide. Okay, as shown in this figure. Okay, we have 3 in a rows of tubes, and then the columns would be 1, 2, 3, and 4. So we have 4 columns of tube banks and 3 rows of tube banks. So now, since the question is the same as before, so let's take a look at I've already mentioned about the 7.38 kilopascal about the T saturation, and this is the same as the previous video, but with some modification where we have tube banks. So now if we have a horizontal tube banks, what we have here, we have to determine 1 over n 1 over 4 h horizontal 1 tubes. So h horizontal 1 tubes is already been calculated before in the example 18. Now what we have to do is to determine what is 1 over n to the power of 1 over 4. So we will directly calculate this value. Okay, so the h horizontal for the n tubes, okay, equal to 1 over n 1 over 4, okay, h horizontal 1 tube. So n to the power of 1 over 4, this n value is the number of tubes in a row. So we have 1, 2, and 3. So 3 number of tubes in a row. So therefore that n value will be 3. So 1 over 3 to the power of 1 over 4. So h horizontal 1 tube is from example 18, where we have 9294. So now we get the h horizontal for n tubes is 7062 watt per meter square dot Kelvin. So that is our value for the h horizontal. So the equation is the same as before, where we have to find what is the q dot, rate of heat transfer. So the question is the same. The first one, A, is rate of heat transfer, and the second one is rate of condensation. So what we have to do is to to calculate what is the q dot. So q dot, we know that the equation of q dot is H AS times with T saturation, okay, minus T S. So now we have to determine what is the AS. So since this is the tube bank, so AS is a little bit different. So before this, for the 1 tubes, we know that the calculation is by dl. So this is 1 tube. So if we have n number of tubes, so the total number of surface area will be n total, okay, by dl. So n total represent number of tubes in that tube banks. So our number of tubes in the tube banks will be 12 tubes, okay. So we have 12 tubes, and then pi, okay, times with 0.03 times with 1 meter. I assume the length of this tube bank is 1 meter. Each of the tubes is 1 meter. So if you want to remain it as L, it's okay. Okay, now it is better for me to assume 1 meter, since I don't want But when I assume that this value is 1 meter, the length of these tubes is 1 meter, therefore the Q dot will be for the 1 meter tubes. Okay, so I will get that the value is 1.1310 meter square. So this is the total number, total surface surface area. So after that, you will substitute into the Q dot value, since you already determine the H horizontal end tube and then the AS. So substitute into that equation. So I will get the value for the Q dot is 78870. Sorry, not 7879. 79,870 watt. So this value is per 1 meter length of tube. Okay, next, the second one is to find what is the m dot condensation, the rate of condensation. To find the rate of condensation, we will use this equation, Q dot equal to m dot H star F G. So H star F G, I also already explained to you from the example 18. Please refer to that video before you watch this video. So HFG already determined in example 18, since this is the continuation of example 18. So rearrange the equation, we will get that m dot is Q dot over H FG. So substitute all the values inside of this equation. So you will get that the value for the m dot is 0.0328 kilogram per second for 1 meter tube length. Okay, you already answered the second question for the rate of condensation. So thank you.